So separable differential equations are going to be anything with a y prime or a dy dx in it, in which case we're solving to get back to the original equation, which is y. So really the steps here would be, if we see something with a dy dx and we're trying to solve for y, the first step is to get all the y and dy on one side, and then we're going to get the x and dx on the other side. And since we have a dy and a dx, then the third step would be to integrate both sides. And don't forget about the plus c because there's no endpoints. And step 4, which is kind of optional, it really just depends, would be if they give you an initial value. So they give you some like y and x value, then you solve for c. If they don't, then we just have our answer. So we'll do a couple examples. So example 1, like I said, we want to get the x is on one side, the y is on the other side. So what I always kind of do first is just multiply both sides by dx. And so we have x squared plus 1 dy equals xy dx. And then we'd think, okay, we can divide both sides by y to get the y to the other side. And we'll divide both sides by x squared plus 1. And so that gives us dy over y equals x over x squared plus 1 dx. Then our next step is going to be to take the integral of both sides. The integral of dy over y is ln of y. Technically it's plus c, but we're not going to really worry about this plus c because we're going to have a plus c on the other side. For this integral, we're going to have to do a u substitution. U is x squared plus 1. That makes du 2x dx. So I do have the x dx part. I need to add in a 2 or multiply by 2, which means I need to multiply by 1/2. So it gives us 1/2 the integral of 1 over u du, which would be the ln of y equals 1/2 the ln of u plus c. So notice we put the plus c on this side. The reason we don't need on both sides, if I had plus c here and I subtract by c, a constant minus another constant would just still be c. So now we want to solve for y. To get rid of the ln, you take e to the power of both. So that cancels. This is like having e to the power of all of that. So we get y equals e to the power of 1/2 ln of u plus c. Now there's a rule in math with exponents. If you have like x squared times x cubed, they add x to the 5th, right? 2, it's like x to the 2 plus 3 equals x to the 5th. We can go backwards here. So because we have e to the 1/2 ln of u, that's like the 2, and then plus c, which would be like having the 3. We can separate those. So we have e to the 1/2 ln of u times e to the c. Now, e to the c is just another constant. It's 2.7, which is a constant, to the power of a constant. So this is just like a new c. Sometimes they'll call it like c prime or just still c. So I'm just going to say this is e to the 1/2 ln of u times c. If you want to call it like c prime for a new c, you could. Or c2, something like that. And usually we'll move that to the front. So we have c e to the 1/2 ln of u. Now, I do want to get that u back, and the u was x squared plus 1. We could have done this earlier. I kind of waited a little bit. So we have y equals c e to the 1/2 ln of x squared plus 1. And now with this 1/2, we have 1/2 ln of x squared plus 1. So we need to know our exponent logarithm rules. So when we have anything with an ln, a log, a coefficient, the rule is it can come up here and turn it into an exponent. So this gives us y equals c e to the power of ln of x squared plus 1 squared. And then when you have an e and an ln, like e to the power of ln directly, that cancels. So this becomes y equals c times x squared plus 1 squared. And that's our answer. Now, if they had given us some initial value, like let's say they had said at, x equals 0, y equals 4, something like that. Then we would plug this in. And so if they had said something like that, we could plug in like 4 equals c times 0 squared plus 1 squared. 4 equals c times 1 squared, so 4 would be c. And we plug that back in, so we get y equals 4 times x squared plus 1 squared. And that's really it. The one thing you will notice on the homework is some of the times they just say, for example, number 1. So that y prime, we're just going to rewrite it as dy dx. That way we can separate. And then I usually do this in one step, like times dx, divide by y squared, divide by y squared. And so that gives us dy over y squared equals x dx. Take the integral of both sides. This is y to the negative second power, so it becomes y to the negative first over negative 1 equals x squared over 2 plus c. That gives us negative 1 over y equals, I'm going to just write this as a half x squared plus c. Now, if I have something like this, I want to solve for that y. I do need to flip, reciprocal both sides. So this would become, if I took the reciprocal, become y over negative 1 equals, now I need to take the reciprocal of all of this. So it's like 1 divided by 1 half x squared plus c. I can't separate it. That's kind of killing a bunny. It's all together. Then I can make this y equals negative 1 over 1 half x squared plus c. Now if I want to get rid of that half, times 2 times 2 times 2, right, like multiplying by 2 over 2, that gives us y equals negative 2 over x squared plus 2c. However, 2c is just another constant, so I'm just going to call this negative 2 over x squared plus c. Now notice, just one thing to watch out for, that c value will be different than this c value up here because it got multiplied by 2. So sometimes people will call it like c2 or something like that, like a new c or c prime, but that's really that. In this case, it didn't give us any initial values, so that's our answer.